So without further ado, I would like to introduce the first speaker today. That would be Philippe Sayegh from Versys. Versys is a cognitive computing company specializing in the next generation of artificial intelligence. The release in cooperation with Denton's US and the Spatial Web Foundation on June 8, 2023. As Chief Adoption Officer, Philippe has a responsibility for formulating the company's overall adoption strategy, as well as ensuring that the execution of the adoption strategy remains consistent with the brand identity. The adoption process covers awareness, acquisition, and advocacy. Philippe has been part of the Versys executive team for the last 4 years. He is a tech entrepreneur, he is an investor, and has 2 decades of operational experience for B2B focused tech companies. Without further ado, let us welcome Philippe.
Good morning, everybody, and thank you very much for this kind introduction. I am both delighted and honored to present to you this morning. Hopefully, I'll have the opportunity to be there physically next time. So let me start by sharing my screen. I'm going to be taking everybody this morning through a journey through a presentation about AI, a presentation about the spatial web, a presentation about Versys, and share with you what impact this may have on the world of transportation and logistics with a specific focus on that. So our goal as an AI company is to enable the transformation of society for the better using smart software. We're building what we call smartware, which is new kind of AI that operates like humans do. It's inspired by the cognitive processes of nature. And these algorithms and these agents, as we call them, can perform cognitive tasks. They can think, they can learn, they can understand, they can be curious. Joss, you mentioned curiosity as a function, as a core function of the day. They can perform physical tasks, so they can fly drones, they can drive cars, they can see through cameras, they can network together. And our job is building the tools to be able to make these agents a reality. And those tools are inspired by natural principles. They're based on neuroscience, and they're grounded in socio-technical standards. Now, we are a publicly listed company, a cognitive computing company. We have European headquarters in Eindhoven, so not too far from Rotterdam. And we've developed a COSM, now dubbed Genius, which is the world's first network operating system for enabling distributed intelligence. Now, our technology is based on the spatial web standards, and I'm going to be talking to you about that in a second. So in a nutshell, as a company, what we bring are new standards, an AI platform, and intelligence agents based on a new approach to intelligence called active inference. Now, we focus our activity right now on supply chain, smart logistics, facilities management, and smart city and mobility. I'll be sharing with you a video at the end of the presentation to show you exactly what and concretely this looks like. We also pride ourselves in having a very expert and internationally renowned Versys AI team. So we have over 20 researchers in a company that's about 100 people right now. That's a lot of research investments. They're specialized in active inference, machine learning, obviously, but also Bayesian scene graphics and computation phenomenology. And they're all led by Sir Carl Friston. Sir Carl Friston is one of the leading neuroscientists in the world. I think he's ranked #1 right now. He has over 350,000 citations. And he's leading the charge for the team and for the AI research that we're running today. So before we jump into AI specifically, I just want to take you through a brief history where you will notice when you look at the history of the infrastructure and the evolution of the internet, every 15 years, you have a jump in this stack. And right now we're moving from mobile to AR, VR, from apps to AI, from cloud to blockchain. And this fourth block is what we call the spatial web. Inside the spatial web or under the spatial web, you have notions like Web 3.0, Industry 4.0, Society 5.0, Smart City, and the rest. But this is a new paradigm. This is a shift in infrastructure that requires a change in the infrastructure as well. And so when we talk about Web3 and crypto and NFTs and DLTs, we're really at the bottom of the stack at the data space. So what is the issue that we've started thinking about years ago? Operations in real life happen in multi-dimension, at least in 3D. So we're operating physically when you're in a port. Obviously, you have the notion of space, distance, sound, wind, temperature. And we as humans interact with those scenes, with the world, with a multi-sensorial approach, where in reality, pretty much the way you're looking at me right now on the screen in 2D, we follow these operations in 2D. So the enterprise systems are dimensionally challenged. So we needed to find a way to be able to describe the world to machines in a way that we humans understand it in a multidimensional way. So we're moving from a web of pages. So right now, when you navigate the internet, you're going from page to page to an internet of spaces, hence the spatial web. And so this raises what we call a grounding problem, meaning the need to be able to communicate with machines. Today, there are no shared models. We speak in words. I'm talking to you in words right now. Machines speak in numbers. There's no shared language. There's no common understanding. And this is what we strive to build over the last 5 years, a common language, a standard, to be able to translate use cases and share a common understanding between humans and machines. So when you look at infrastructure and technology, people tend to say there's networks, 5G, 6G, an enterprise stack, exponential technologies. I can sandwich all these together and I get a smarter world. There is a fundamental layer or layers that are missing, is our capacity to be able to define identities, activities, and places, define who has the right to do what, where, when, for how long, and under whose authority. Who has the right to move that container? Who has the right to fly that drone over that ship? Who has the right to go inspect that ship? Who has the right to enter that warehouse, et cetera, et cetera? And how do you govern the behavior of those different things? So what we actually did is we rewrote the infrastructure layer, right? So when you're going on internet, your anchor is a URL. Our anchor is a geospatialized point in space with a volume around it. The room that you're sitting in right now, we call those a spatial domain. The chair, one of the chairs that is in that room, is another spatial domain. If I were standing on that stage, I would have my own spatial domain standing on that stage, right? So this gives us the notion of geography, geometry, topography, and HSML is the hyperspatial modeling language, and the hyperspatial transaction protocol are a means to describe and share that description between machines. So the grounding elements is getting machines to understand geography, geometry, relationships, interdependencies between the data, and credentials, rights, permissions, and policies. And so when you do that, when you start being able to describe that world in a common language, you start getting explainability when an AI makes a decision. You start getting trust because you have explainability and understanding of why did that autonomous truck deliver that container to that pier on Monday at 2 p.m., right? You get alignment because there are rules and policies that are shared and understood, compliance and interoperability. And this is very important because these issues are really core right now in the AI space and the development of AI. So the standards that we started developing about 4 or 5 years ago, were deemed by the IEEE, which is one of the largest international standards association, where Bluetooth and Wi-Fi were standardized, for example. They deemed that these standards were a public imperative. So what we did as a company, we actually gave them to the world. So they're not ours anymore. So now they're sitting in the IEEE in a working group with about 120 people from academia, government, and business leaders, shaping and working those standards and language so everybody can benefit from them. And they're also very ethically designed by principle. So we took these standards and we started developing a platform. On top of that platform, we developed agents, call them AIs, that continually see, sense, learn, plan, and act in the world they're navigating in. So on the input side, you have multimodal, so understand it comes from video, audio, text, etc. inputs, so information, and the outputs is a decision that is translated and sent to different edges. They can be drones, they can be cars, they can be devices, they can be vehicles, wearables, cameras, whatever. And so once you get that those agents speaking the same language, they can start communicating with each other in a network. So a container will have its agent, the port will have its agent, a truck will have its agent, a drone will have its agent, a person can have its agent, and then these agents in a simulated world or in a real world as well, they can become interoperable and communicate. And so this is where you start getting an ecosystem of intelligence. You can start having different edges with different levels of intelligence and different levels of sophistication, share information, share activities, share commands, share information about the world they're navigating in. So in the context of a port, you will have the same understanding of what is happening in the port, whether you're Maersk, whether you're CGA, CGM, CMA, CGM, or whether you're a transporter or whether you're a manufacturer, et cetera, et cetera. And so what you start having is a model of the world that is very close to the operational side of it. So we embed in those, we call them smarter twins. We embed in those twins the policies, the activities, who has the right to do what, where, etc. So the use cases per se. And then when we start connecting the results of that simulation to the real world, we start getting operational execution. And so the AI we use is very different from everything you've probably been hearing about over the last at least year. This is not about generative AI. This is about regenerative AI. This is about active inference, where we understand causation. So on the one hand, you have correlation. On the other hand, you have the understanding of why things happen. It's explainable. It's distributed. So we are anywhere, but far from a monolithic approach to AI. It's more a distributed network of agents that kind of operate together. This is how nature works. This is how we as human works. What's happening right now between me, you here, and everybody outside is we're sharing knowledge, right? And for the greater, for the benefit and the greater good of everybody. But it's distributed, and we're self-learning, and in that same way, the agents do the same. So, in terms of our vision of where AI is going, we fundamentally believe and have believed so for the last 4 years that we're moving toward a more nimble, more flexible model of independent agents, many of them, actually thousands, millions of them, networked together, talking the same language, sharing the same understanding of the world, learning off of each other, asking themselves to do different tasks, etc., and getting an ecosystem of intelligence out there. So we are not at all about scaling a big monolith where you have like a big monolith where you're throwing in data and using a lot of power and energy and tweaking to be able to extract intelligence. If you look at what's happening in nature, if you look at the way your body operates, it's all about a network of different intelligence. So the reason we believe this is happening, right? So it's not we don't think it's a matter of if it's going to happen, it's a when it's going to happen. And the benefits are phenomenal because we are going to be able to tackle world scale problems from logistics, obviously, which are at the heart of improvements that we can bring, but also you can tackle health issues, you can tackle climate issues once you start having the network and the artificial intelligence that goes with it. And to get to this smarter world, what we're doing is taking those intelligent agents based on this approach called active inference. And if you're curious, I would very much encourage you to look it up and educate yourself about it. We're obviously very happy to share information should you want to. I'll leave you my email at the end. And we're going to get to a stage where there's going to be an increasing number of autonomous intelligence systems based on standards, understandable explanation that bring birth to the ecosystem of intelligence. So this is how we are striving, providing the tools for others to unlock a smarter world. Now, this is all the theory and the concept behind it. I'm going to take about 3 minutes and share a video with you to show you what this looks like. But you can totally imagine when you're starting having a network of intelligent agents working on a port, you can have issues where you can have, solve emergency response issues between a drone that needs to talk to a fire department that needs to talk to the transportation company. You can have a multi-agent governments where you can have, trucks synchronizing their activities with drones, with warehouses, or you can have infrastructure maintenance. So setting off autonomous drones either on cranes or wherever to boats to kind of look at how the infrastructure is. The feeds, the video feeds and the pictures could be sent to a backend where this is analyzed, and then you get a state of your crane, a state of your boat. I know today that you have obviously drones going and sensing the fumes coming out of boats, etc. So on that note, I am going to probably stop sharing my screen and let the video play. Is that what I'm supposed to do? So I'm not sure if you can properly hear me, but what you're seeing there is we created a digital twin of a space here in Eindhoven. We've explained to the AIs the weather conditions, the physical obstacles, the potentials, the legal policies, where they can fly, where they can't fly, and we give them a mission, which is going and doing an infrastructure inspection of the building. And so the drone autonomously flies out, calculates its direction and its path, goes and does the inspection, and then flies back and lands and sends that feed back to the back end. Now, what's really, really super interesting here is that we've managed, and I'm going to show this in a bit, to translate legislation for drones, like legal text, into machine executable code. And this is what you're going to see. And this is super powerful because then you start getting compliant behavior by design of any type of AI. So using the standards, we've translated the legislation for flying drones, and we can apply this to anything, to processes, to data, to any type of legislation. Cars can be legislation for a policy specific to a port, like Rotterdam. So we take the rule, we parse it, and then we transform it into HSML, where we identify who has the right to do what, where, when, and how. Now, any AI running on HSML can understand that rule. This drone can fly here, this drone can only transport this type of information or this type of merchandise, and then apply them. We can control altitudes, we can decide how fast they can fly, where they can fly, what rules they change. So imagine a drone flying from the Netherlands into Belgium, or from Belgium to France. As soon as the drone crosses the border, the policy automatically updates and the behavior of the drone changes accordingly. So this is super powerful. And this is very useful because then it makes the AI's behavior both compliant and explainable. Compliant and explainable. So on that note, that's what I had for you this morning. Thank you very much. I was very happy to have the opportunity to share this with you. I'm open to take some questions. I don't know if we're good on time or not, but Bart and team, this is your call.